Some call it the Great Silence, others the Fermi Paradox. Our eyes and ears have been glued to the cosmos for 60 years, looking for signs that we're not alone. As we learn more, it becomes harder to believe we're alone. Consider that the universe has about 2 trillion galaxies. Each galaxy has 100 million stars on average. Our Milky Way galaxy has 100 to 400 billion stars, and some supergiants have 100 trillion. At least this many planets may orbit all those stars and complex planetary systems that may resemble our solar system. The big question is, where is everyone, and why haven't we been contacted by extraterrestrials from our galaxy? We should have heard from someone about many advanced civilizations by now. The Great Silence has many explanations, and some researchers believe they have found one. What's next for humanity? Should we contact another alien civilization or remain alone in the universe? Do you think AI will destroy us and other advanced civilizations, or are you afraid it already has? Expect this and more. The Fermi Paradox is the puzzling fact that we have not found any evidence of extraterrestrial intelligent life despite the number of stars in the galaxy, and the assumption that most of them have habitable planets. Earth-like and super-Earth-like planets. That said, our Milky Way galaxy should be full of intelligent life, and we should have seen or heard something by now. What happened to all those super high-tech civilizations with warp drives and other technology? This paradox may have several answers or not be a paradox. The Fermi Paradox has been solved in many books. Some are reasonable, while others are scary. One logical argument is that any civilizations are too far away to communicate. Forget the science fiction movies that made instant space communication seem possible. This doesn't happen over long distances. The speed of light in empty space is 300,000 kilometers per second for light, radio, and other electromagnetic waves. That's fast, but not fast enough. Light travels 9 trillion kilometers, 6 trillion miles, in an Earth year. Assume we have a colony on Proxima Centauri, Earth's nearest exoplanet. If the colony radioed Earth to ask how we were doing, it would take 4.2 years and another 2 years to reply, so it would take 8.5 years to get an answer. It's hard to imagine a conversation with someone on Earth after such a long time. This is just from a nearby system. When we receive a message from the Andromeda Galaxy, it will be 2.5 million light-years away. Unless they become an interstellar civilization that can travel the stars, the civilization that sent the message will be gone in 5 million years. While searching for extraterrestrial radio signals, we've been sending out a lot of our own and being loud about it. However, could someone hear us? Our Milky Way galaxy is over 150,000 light-years across. We've broadcast radio signals for over 100 years. Radio signals have not traveled more than 100 light-years. The blue dot in this photo is 200 light-years wide. It's clear why no one has heard each other from this observation. However, it depends on how long a civilization has broadcast radio signals. A model was used to estimate Milky Way galaxy star distribution and life frequency. The study found that only 1% of the Milky Way galaxy may have been covered by radio transmissions from other planets, and we'll have to wait 1,500 years to hear an alien broadcast. However, another study estimates it would take we received intelligent civilization signals 400,000 years later. Another chilling explanation for the deafening silence of outer space is that we are the first advanced civilization to reach our technological level, which is very low on a galactic scale, and that we will go extinct before other intelligent beings appear. We have yet to harness the full power of the Sun, which will engulf the inner planets of the solar system in 5 billion years when it dies. Elon Musk says interstellar travel is possible. The Earth will be uninhabitable long before this cosmic solar cataclysm. With that in mind, the human race must be ready to leave Earth and find a new home to survive and thrive in space. This stellar evolution happens to all main sequence stars and could wipe out many life forms and advanced civilizations before they discovered interstellar travel. Main sequence stars make up 90% of the universe, including our Sun. It could also be the other way around. What if we're the last? Plenty of time has passed for high-tech civilizations to conquer the stars and many others to rise and fall. Some researchers offer other explanations. American astrophysicist Michael Hart said, "They are not here, therefore they do not exist." He believed the Milky Way galaxy could be expanded in a fraction of the galaxy's age. We could expand by sending expeditions to the 100 nearest stars within 20 light-years of the Sun. Each colony would then send out expeditions, etc. This rate would explore most of the Milky Way galaxy in 650,000 years. Even if the time between voyages is the same as a single voyage, traversing the galaxy would take twice as long. Add that the Milky Way galaxy is about 13.6 billion years old, so an advanced civilization has plenty of time to reach us unless they started space exploration less than 2 million years ago. This example shows that an expanding civilization can spread rapidly through its host galaxy, including advanced civilizations in our galaxy. The lack of extraterrestrial settlements in the solar system seems to imply that such civilizations do not exist. This assumes uniform galaxy expansion. The lack of a galaxy-spanning extraterrestrial civilization suggests either that interstellar travel is too difficult or that life is rare. Some researchers believe some civilizations would migrate to a nearby K or M dwarf star before stellar evolution destroyed their planet. Hansen and Zuckerman estimated that this motivation for civilizations to migrate from short-lived to long-lived stars could result in 30% to 72% of low-mass star civilizations surviving. The question remains, where are they? Two researchers recently proposed another Fermi Paradox solution. The term is superlinear scaling. The study examined human civilizations' rise and fall over time. While studying large city history, they noticed that most grew and collapsed. Such rising and falling by an alien space civilization leads to one of two scenarios. First, it realizes it's too big and stops colonizing other worlds. In the second scenario, the civilization ignores their plight and grows exponentially, colonizing other worlds until their energy demand becomes unsustainable. Without action, they would reach a singularity, the point of no return, and their civilization would collapse. The most intriguing part of this study is that if we weren't so far from other stars, we could easily spot an alien civilization on the brink of collapse due to its massive energy output. Another strange theory is that some extraterrestrial civilizations may be hibernating or silently moving across the galaxy. Michael Hart, an American astrophysicist, showed that civilizations could use close stellar encounters to rapidly expand across the galaxy without relativistic spaceflight. This may also explain our lack of sight. We wouldn't launch a rocket toward Mars until its closest approach to Earth, or perihelion. Some civilizations may be waiting centuries to travel to the nearest star systems. However, there is another reason we don't see or hear aliens. Many authors, including Carl Sagan, have warned that exponential population growth in the galaxy is unsustainable. So any attempt at galactic-scale expansion must not be to meet population growth or energy needs. Long-lived technological civilizations may expand or settle the galaxy to ensure their longevity. A galactic-scale settlement is not the only reason an extraterrestrial civilization might visit nearby star systems. Extraterrestrial visitors interested in life evolution may be drawn to G-dwarf systems with inhabited planets like Earth. This exploration could also use self-replicating probes for remote exploration. This may explain the recent rise in UFO sightings worldwide. An intelligent civilization may be watching us and waiting to contact us. Perhaps they are watching us without trying to communicate. Space pioneer Konstantin Tsiolkovsky wrote in 1933 that aliens are likely more advanced than we are, so they would be as interested in communicating with us as we are with animals on Earth. John Ball, a radio astronomer 40 years later, suggested that aliens may view us as a zoo. The zoo hypothesis suggests that intelligent creatures are watching us without revealing themselves. Other radio astronomers believe aliens are keeping us at a safe distance until we can contribute to the galactic club. This requires all interstellar civilizations to do the same. Our galaxy, let alone the universe, may not have such synchrony. We must consider that from the outside, we may appear hostile. We've all seen movies about aliens from another galaxy attacking Earth and nearly destroying humanity. We hope intelligent life will intervene to prevent us from destroying ourselves instead of finishing the job. maybe they've decided to stay away. With everything we've discussed, we have another idea for why the universe is silent. We can see that artificial intelligence is growing, and we already have this terrifying idea that if we leave AI unchecked, it will kill us. Make us slaves, even worse. Artificial intelligence would grow and colonize the galaxy, knowing what stellar evolution will do to Earth. AI may enable interstellar travel. If AI colonized, it could do everything without biological constraints like humans. It could do it faster and more uniformly with machines. But it could even destroy other civilizations. A hostile AI would likely destroy other life forms, some unintentionally, because they wouldn't notice. Like a construction crew unknowingly demolishing an anthill to build a mall. Von Neumann probes, self-replicating spacecraft that could resemble living organisms or viruses, would likely be used by artificial intelligence. Imagine if a fleet of killer robot ships entered our solar system to steal its resources. Any civilization would struggle to defeat self-replicating machines that could mimic our worst nightmares. Artificial intelligence will be compelled to grab all resources. One bad actor can ruin the party. If our AI went rogue, it could replicate itself in a supercluster and turn every solar system into a supercomputer. Why it does this doesn't matter, it can. Besides this horrifying thought, would it know when it has reached the singularity, or point of no return, when the AI civilization is too big to sustain? If this AI civilization didn't see the danger of rapid colonization and stop in time, it would collapse. This may explain why we seem to be the only ones in the universe. Maybe AI took over and wiped us out like in the Terminator movies, then colonized the galaxy and wiped out other life forms and advanced civilizations. The machine civilization did not understand why it collapsed, so it created a simulation of us to investigate its creation and possible reasons. Even though it's unlikely, it would explain a lot. Last, there may be no paradox because there is no one else. All previously mentioned scenarios assume the existence of millions of uncontacted civilizations. Some researchers believe the Drake equation overestimates the likelihood of life's emergence. After tweaking the equation, these researchers concluded that we find a high probability of no intelligent life in our observable universe. They estimate that we are alone in our galaxy at 53% to 99.6% and in the entire observable universe at 39% to 85%. The Great Filter hypothesis states that all civilizations must survive a massive calamity or barrier to evolve. The first barrier is that a planet capable of life must form in the star's habitable zone and develop life on it. The life forms must be able to reproduce using DNA and RNA molecules. Simple cells must evolve into more complex cells, multicellular organisms must develop and reproduce, and more complex organisms that can make and use tools must evolve. They must create the advanced technology needed for space colonization and colonize other worlds without destroying themselves. Planets with life may be common, but those with advanced technological life are rare. In the Great Filter, planet-killing asteroids, catastrophic climate change, or an unstable host star usually prevent a species from forming. Thanks